Welcome. Do you want to join in? I'm just starting.
And just before you start,
Oh.
just a reminder, if you have a question, just yell, shout, and I'll bring the mic. And I think we're still on mute. No, we are. Okay. So just shout if you have a question, and I will monitor the chat as well and bring you those questions. Up to you, Darren, for this part on the second part of integration services, FaaS.
Thank you, sir. Okay, I'm going to straight dive into the topic because there's a lot that I want to cover as part of this session. Function as a service. And I wanted to title this like, for everyone, everywhere. So what does that mean? Let me explain. So when we start talking about functions, it's, for those of you who are not into heavy, deep into development, you can imagine like, maybe the stored procedures in databases. So I have a piece of something that I want to run. It's a relatively small piece, and I need an environment to run it, right? The starting point, if we would compare this with the competition out there, and that would be primarily, I would say, AWS Lambda, the starting point would be the need to connect different services that we have in the cloud. The simplest scenario would be, hey, I have S3, I'm uploading a bunch of files. Every time I upload a file, I want to send an email. So the cloud provider does have the email service. It does have the storage service, but how do I connect the two? This is essentially where the function as a service thing gets into this concept of being a glue between multiple services, right? This is where it all started. Then, we started customizing the triggers. What is the trigger that essentially kicks off whatever process is going to happen, right? A file upload may be a trigger to trigger that whatever is going to, the piece of code that is going to run and connect to the email service provider and send the email. So what if we can customize those triggers? What if an incoming HTTP request was a trigger, which literally is the definition of a REST API, an HTTP API, right? And then the other end of the pipeline, if you consider like the incoming trigger as the start of the pipeline, the compute in the middle as the processing, and the output of this pipeline being something else, right? The email service connector at that point. Can we help out customers on that front as well? And then there's a huge, I know I'm kind of, whatever I'm going through is not necessarily connected to the slide right now, and I will connect it to it. But one thing that is important to understand is when we talk about serverless, it's a little bit confusing because when you talk about serverless, is that microservices? Is that containers? Is that a development architecture? Or is that simply a licensing model? So let's keep that question hanging out there. And let's go slide by slide. The first thing I wanted to mention is, this is one of the competitive advantages that we have. The first couple of slides will be about, the fact that Azure Functions is something that you can run everywhere. And by that, I mean you can run it on premises. You can run it in AWS. We have customers using it on AWS. You can run it in Azure, obviously, if you want it. You can take the runtime, run it wherever you want. And we don't charge for it if you run it outside Azure, right? So it's kind of interesting. I'm sure for those of you who are in sales, like right now it's a shut off, like, hey, can't we charge for it? Yeah, I mean, it's a crazy sticky service though. Once you start developing something with Azure Functions, the function as a service model, it's really very hard to move away. But the runtime is something that you can take away, right? But I will talk about a couple of dependencies that might not make it really easy to move away though. Primarily it's the Azure storage, because the function runtime is, a lot of the scenarios are reliant into the Azure storage subsystem. So if you want to move it to the on-premises, and if you're using those functionalities, then you really have to go with the Azure Arc path, where you can have a local storage subsystem that you can enable the Azure Functions on-premises. It's not like a random thing that you can use wherever you want. So yeah, let's fall back for a moment. So those are all of the languages and stuff that we can use with Azure Functions. The one thing that is important to mention is the custom handlers. I will talk about that, what that means. That means you can bring pretty much anything you want. Any programming language, any runtime. I mean, the ones on the top, they are officially supported. But the one on the bottom, simply says, hey, I have an extensibility point where you can plug in whatever you want. But if you're plugging in your own thing, obviously you're going to be responsible of it. So what do you mean with custom handlers? Yes, this is kind of a high-level definition of it. Essentially, bring your whatever executable that runs. It's literally an executable file. You bring that in, you plug that in into the functions runtime, and you are hosting it as a serverless. So this sentence is actually a critical one because you are hosting it as a serverless. Means that within this context, I'm using serverless as a licensing model. What does that mean? So let me actually go here, because this is important. The first line, the consumption model. So when you go into Azure and you host your Azure Functions app in the consumption tier, that means you will be paying for the amount of milliseconds you used and the memory you used during that time span. So there is no better, more granular way of hosting any workload in any cloud. Imagine you have a piece of code that you want to run. You are deploying it. It's in Azure. You're not paying for it. It scales down to 0. Like container apps kind of does the same thing. But the granularity of the billing, the unit is milliseconds. It's rounded up to seconds at the end of the month, but it's milliseconds. So every little optimization that you do, if you save 10 milliseconds for every API call at the end of the month, you might be able to save $10,000 or whatever based on your scale, right? So the engineering effort invested, you see the end result, the return on investment, instantaneously. And the whole scaling that we have backing up Azure Functions is totally event-driven. What does that mean? How many files you have uploaded? It's going to work based on the number of files you get. Those triggers. How many times those triggers are being called? The underlying system will scale based on the number of events that comes in. You're not going to need to set up anything. I mean, the upper limit right now is 100 servers. And you can extend that with some workarounds, but up to 100 servers, the runtime itself will decide to scale your application down and up. And here's the interesting part. When you, for example, scale an AKS cluster based on your load, right? So you added a new VM into your cluster. You start paying for it. It doesn't matter if you fully utilize the server or not from an AKS perspective, right? Here, when your application is being scaled, when Azure decides to add another server behind your Azure Function app, you will not pay for it. You will still pay for the amount of milliseconds of compute your code used. So if Azure decided to add another server, just because you need an additional incremental 5% compute power, you will still only pay for the 5% that you used. It doesn't matter. You simply do not care how many servers Azure decided to throw into your cluster. As long as your code is built to scale, in a distributed fashion, right? You follow the best practices in terms of that. You don't have to worry about anything. It's going to do it itself, and you will still be paying for gigabyte per second. So I'm going to go back for a moment. So we did talk custom handlers. So the other question is, can I bring anything? So you mentioned like, hey, custom handlers, I can bring my own framework. Can I bring anything? Not a framework, a custom whatever, dependencies that I would like to install and stuff. Yes, you can bring in your container. Custom containers, you have to start from the base container that we provide. One limitation is that we kind of support this for Linux containers, right? It has to be a Linux app service that backs up the Azure function. I will talk about what does that mean. What is an app service backing an Azure function? I will talk about that. But there's a premium tier and the dedicated tier. The consumption tier right now, at least, it's not available for the container-based deployment of Linux functions. If you go zip deploy for Linux functions, you can use the consumption tier. So again, there are some parity issues between Linux versus Windows, at least for now, but it's coming. Okay, so we did talk about the consumption tier a little bit. Then the premium tier. When it comes to the premium tier, you are getting provisioning virtual CPUs, virtual processors, and memory for a particular duration of time. It's not per millisecond anymore. You're getting dedicated cores, You still have elasticity in terms of being able to scale the app service that backs up the whole thing. It auto scales again out of the box. You still enjoy that. So there are a couple of limitations with the consumption tier. For example, you cannot have, I guess it was 10 minutes. You can not have a function that runs longer than 10 minutes in one run, right? A single execution, round cannot be longer than 10 minutes. If you want to go longer than 10 minutes, you have to go with the dedicated tier and so on and so forth. And this is where, when you look into the industry, when we start talking about serverless, we actually refer to the consumption tier, okay? Because the biggest advantage of serverless is the fact that first off, it scales based on events, and I only pay exactly for the resources that I have used. I don't have there's this, like 5 or 10 years ago, we were all using slides where we were showing, hey, here is the consumption and here's the provisioning, and the delta between your provisioning and your consumption is the unused resources that you have provisioned, you are paying for it, but you're not using. As close as I can get those two lines, you are, efficiently using the underlying platform. So the Azure Functions is the closest thing we can get to it. So literally, and this is an actual scenario that I am going through a customer right now. Literally, you can bring down a 5K bill down to $500. So that's the level of, and this is extreme case because you're moving from a VM-based deployment to a serverless deployment, like you're going from the dark side to the bright side, whatever. But it does happen. So oops, this is the third time I'm hitting that. Anyways, dedicated app service premium v2 won't also scale unless you do. The important thing to keep in mind maybe here is the letters for the SKUs, because when you provision a function app, you're going to see that it's actually wrapped into an app service plan. That app service plan is set to the consumption tier. It's an app service plan where you can only deploy function apps, right? It's simply a wrapper from an ARM resource deployment perspective. It doesn't serve any functional use in terms of the end user, but it's out there, so you're going to see that. When you go with the premium tier, you're going to select SKUs that starts with E, and for dedicated, you're going to select with P. When you go with P, there's no auto scaling unless you specifically set it up. Okay. So sometimes what customers do is that they already have an app service plan with, for example, 20 servers, right? And they already have some leeway. They sometimes want to put their function app within the same cluster with their other app services into the same app service plan, just because they have it in a VNet or whatever, right? Or they like that intercommunication between the function app and the app service happening within the same app service plan, closer to each other within the cluster setup or the data center. So sometimes they prefer that. Okay. Am I stuck with public cloud? I mean, we did kind of touch into this. Azure Functions has two pieces. It has the runtime and the scale controller. As the name suggests, the scale controller is what decides to spin up new instances of the function app for you based on the number of events triggered. The scale controller is not something we freely share. So we don't give that. It's proprietary. But you can have the runtime. It's open source, by the way. You can run it wherever you want. We have a container image for that. And if you connect it with KEDA, the event-driven scaling of Kubernetes, then you pretty much could go into the same, have the same functionality, right? But the function app is not just something, a piece of code that can be triggered. It has a development framework behind it. And I will show you what that is. But the goal is to make the developer's job really easy. What does that mean? For example, when there's a file uploaded into a blob, you have a couple of options. How are you going to be notified about it? As a developer, you're writing some code, you're doing an implementation. Your first option is maybe to go to the blob and blob storage and check for the list of blobs every 5 minutes, do some kind of a polling, right? So, and if you decide to do so, let's say, are you going to implement the raw REST APIs of the blob storage and send HTTP calls and stuff? No. The product group is trying to make things easier for you. So what you're doing is, as part of your C# code, you're actually decorating your C# function and saying, hey, this function will be called when this storage account, this container has a new file in it. That's it. I'm writing it as a meta attribute on my C# function. So the connection with the service is implemented by the underlying framework itself. So it's additional added value that the functions runtime brings in. And it has support for all of the languages that I did, list at the beginning. So the Docker container-based image, seamless support event. Okay, we did cover all of that. So this is another thing that you're going to hear. The moment you start having those discussions with customers, like, hey, should we go with the isolated process? I'm going to go through this really fast. But here's the gist of it. So the first time the Azure Functions runtime was coming up, the product group was coming up, it was purely, mostly .NET. It wasn't purely .NET, but mostly .NET. And it's kind of funny because the first time really Azure Functions came up, it was only JavaScript. Then .NET came in. And when they built the .NET runtime, it was tightly coupled into the runtime itself. And by runtime, I mean this thing that hosts the application, right? So you got two pieces, your app and the runtime, and your app has to talk to the runtime, right? So this connection between that, the talk, can either happen within the same process, right? Imagine like you're running a plugin in Word, and the plugin lives within the sandbox of Word, right? When you close Word, the plugin is dead. When the plugin crashes, it might crash the Word process as well, right? Sometimes that happens. So it was how it all started. Then, because this tight coupling was making it hard to support different languages and runtimes, the product group decided to separate the two. Okay? This is why it's called. Where am I? Okay, this is why it's called an isolated process. The isolated process disconnects the two. It creates an additional level of abstraction, let's say, and it helps the product group to support more languages. This has happened maybe 2 years ago, but because of this additional abstraction, a lot of things have to change, right? So I'm not going to go deep into that, but you have to understand, hey, for example, when you go with the tightly coupling, you only have the LTS versions, long-term servicing branch versions of .NET Runtime. If you are looking for the preview, you have to go with the isolated. The feature is, by the way, the isolated. That's where we're going to go. And that's where you can use the full power of the relatively new .NET Core, because, for example, if you have the two tightly coupled, let's say you decided to use a library in your app, an external library. And for some reason, the product group was using the same external library. They were using version 2. You want to use version 3. You are screwed. You can't do that because you are in the same house. You cannot use two different versions of the same library in the same house. You have to separate houses, get to an Evo partner or something, right? So the isolated process solves that problem. When you abstract the two from each other, this one can be using version 2, this one can use version 3 because they're isolated, they talk to each other separately. So that kind of, less dependency conflict is where this comes from. And dependency injection and middleware are the features that you can implement because you have your own house, right? You can do all of that. Okay, so let's look into this. So here I have a small example that I want to show you. Where are we? Okay, this one. Can I make this smaller? Okay, and make bigger. Can you see it? Should I make it bigger? Okay, this is too big, but anyways. So here's what's happening. I'm going to go through this very fast, but what I wanted to do is, when someone uploads an image into my storage, I want to resize it to 2 different sizes. That's all I want to do. Okay. So usually how developers approach this is they make this functionality part of their application, right? And then, nowadays, I'm sure you're hearing a lot like, we want to separate things, we want to do microservices and stuff like that, right? So what if I had a piece of code that I want to run that will be triggered every time any file is uploaded and then resizes and stores it, and I only pay for this infrastructure every time a resize operation happens? That's pretty much like a store procedure type of thing. Like when you have an insert, I want to insert into 2 other tables, right? That's pretty much it. So here's what's happening. We don't have to go through the implementation details of this function, but here's what's important. I got a function. This is a C# function that any developer can write. What I'm doing is I'm decorating this with this meta attribute. I'm saying, hey, this is a function. you know, Mr. Runtime. This is a function called image resizer. And I want this function to run every time there's a blob upload to the container name sample images. I am defining a variable that will hold the name of the blob. So at this point, I know that this function is recognized as a function by the runtime. And this is the container. How do I know where this container lives? There you go, the storage connection string from the configuration. This is the key that I have actually here. Okay, somewhere in here. Yeah, this one actually. So here is my connection string to the storage account. And I am using that. I am telling, hey, this is the storage account. And I want to be triggered based on blob uploads. Here's the container and hold the name of this file. So when I scroll down, and you're going to see that this has a return type, my output type. What is that? When I go into my output type, I am returning two different outputs. Those are byte arrays holding the image data, the raw image data, right? Image small, image medium. What's important here is those variables are actually decorated as well. So I'm saying, hey, this variable, this is a blob output. This is going to be stored in this container. Use the same name. Use the same name that you captured up there. Here's the connection for the storage. This might be a different storage, by the way. In this case, those keys, they map to the same storage system, but you know, it doesn't matter. These can be different storage systems. This can be across data centers, whatever, right? And if you look at my code, I am resizing the images and so on and so forth, and I'm assigning the content of the resized images into these variables that I've created, and I'm returning the output. So this function is being triggered when a blob is uploaded, right? It captures the name from the container. This is, the input array is actually the content of the originating blob. So I don't even go out there and read the blob. The runtime does it for me. It knows where, you know, it detects that there is a new file. It captures its content and gives it to me as a variable so that I can work on it. My implementation is totally disconnected from the APIs of Azure Storage or whatever.
So when you're defining the trigger in the code, how often is it polling? How often is it looking for the image? Are you paying for that? Or how does that work in the backend?
Beautiful question. First off, I don't remember the default time. Let's assume it should be somewhere around 30 seconds to 1 minute, at least based on my personal experience with the UI. But there's a polling. You can configure that. There's a file called host.json in here. You have to look up the documentation. There is a way to define an additional parameter here that tells the underlying runtime how frequently to do the polling. For the polling, yes, you will be paying as part of your Azure storage bill because that's going to be the transaction against your storage system in terms of REST API transaction plus the egress, and all the bandwidth and all that stuff. And there is going to be a little bit of additional payment. So here's the deal. So this function goes and detects a new file that is uploaded. How does it know that the other file was already processed? So I'm not going to go into the details, but there is a behind-the-scenes work that is going and tracking the already processed blobs, and that tracking and the metadata that relates to it is stored in your Azure Storage account as well. So there's additional, very little tiny overhead that you are paying for those operations as well. Right?
It's kind of like a backend event hub.
Sorry?
It's a backend event hub.
It's not event hub. It simply goes, the default implementation is simply going, using Azure Storage Queue, another blob as a lease and lock to ensure, and there's blob receipts. It doesn't use event hub though. Here's the alternative though. Instead of doing polling, and this is something relatively new, you might have heard about Event Grid. Okay, so Event Grid subscriptions is like relatively new, again, last 1 or 2 years. There's native support from Azure Storage for Event Grid publishers, and this blob trigger has actually support for it. You just have to define an additional parameter in it to say, hey, I want you to use Event Grid-based subscriptions instead of polling, and you can do that. If you do that, you're not doing any polling at all. event grid, events will come to you through eventing, and all of the fluff behind the scenes will disappear as well. So it's going to be more efficient from polling, both from a cost perspective and performance perspective.
Thank you.
Welcome. Okay, so I'm not going to run this. Trust me, this works. Because I just figured we have 5 minutes left. Oh, no, we have actually 20 minutes. Okay, cool. That's a relief. Okay, anyways, I will still not run this. The source code is on a GitHub repo I will share. Trust me, it works. My plan was to run those, but I just want to go through more content in here. The other thing that I want to mention is bindings and triggers. So we did kind of see the triggers, right? The blob trigger. And we actually saw bindings as well. But let me show you another example. This is a much simpler example. So in this case, what I have here is I have an Azure storage queue. Someone is putting a message into the queue. I just want to get it and put it somewhere else. Let's assume that I'm doing something in the middle. I'm not doing for the sake of this example, but let's assume that, hey, someone is putting a job into the queue. I'm getting it, doing some work, processing or whatever. Maybe I'm storing some stuff, whatever, right? And then I'm putting into another queue so that someone else can take it, right? So it looks like I have 2 different implementations that I have to do. First off, listen to a queue and then send a message to another queue. And those are, in this case, those are Azure storage queues, and there's an implementation that relates to it. But here it is. Function queue to queue. Okay, this is the name of my function. This means, hey, this C# function is actually an Azure function. And then the first thing, queue trigger. What is the name of the queue? My queue items. Where is the storage connection? Here it is. I mean, the pattern is pretty much the same. And how do you get the queue message? Oh, it looks like I'm just defining a string variable, and it's going to pass the content of the queue item to me without any work, right? It just comes in. And I'm logging, like saying, hey, I processed this queue message. And then here's what's interesting. I am returning a CLR object, a C# object. I'm defining a to-do item, putting the message's content into table, like simply returning a C# object. How is this going to handle that? I'm returning it. What is the output binding? Queue output binding. It goes into another queue from this storage account. But here's the deal. So I have a string message from a queue, but I'm returning a C# object to another queue. And yes, the runtime will detect that this is a C# object. It will serialize it itself. It does the other way around as well. If there's a C# serialized object coming in from the queue, it will deserialize it for you and fill in the C# object for you. So imagine how easy it is to communicate with C# objects, or any language that supports this runtime, through multiple queues and stuff. You don't even, you don't care about the queue implementation, the polling, whatever, and you don't even care about the serialization. You just work with your C# objects that you work every day. So once the customer starts implementing this, they're not going to be able to leave. Trust me, because this means if I wanted to move this to GCP, I would have to write code to handle all of these communications and the serialization and all that. It's going to be really painful. And when they see these functionalities, they pretty much fall in love with it, because if they're implementing with an app in an app service or in AKS or whatever, right? Unless they're on the functions runtime, they're going to need to implement these on themselves. Okay, cool. So let's talk workflows a little bit. Okay, so this is where we're going into the level 400 territory. So when we start talking about workflows, like business workflows and stuff, there are 2 products that stand out. I'm sure the previous session about integration services kind of talked about Azure Logic apps, where you can, move things visually and kind of see the flow, and that's really beautiful. And you can even bring Azure Functions within whatever, boxes into your process, and kind of, do all that stuff here. But the other way to do this is durable functions. So here's the problem. I mean, first off, I don't want to define my workflow in Logic app because I'm a developer and I want to, write it as a piece of code. But the other problem you have is once you start building a lot of functions like microservices, you will end up in a position where you have to have those, functions communicate with each other. Or you will end up in a situation where, hey, I'm reading a file, triggering from a file, doing something, then I have to do something else as well, then it will put something in a queue, the other one will take it, and all of these moving different pieces, right? Multiple functions. How do I coordinate all that together? So you are essentially having a workflow implementation problem in this case. You have a workflow that goes step by step, and because all of these functions are stateless, right? When they run, if they crash, they're not going to be able to resume. You know, if you have one piece of work that has to be handed over across different functions in a sequential lineup, they have to transfer the state from one hand to each other, right? Either through the message queue or whatever. So can we make it easier? Okay, so we have this thing called durable functions. This is relatively tightly coupled with Azure Storage. This works with Microsoft SQL as well. So if you're going, on-prem, maybe you back this up with, Microsoft SQL. And there's another runtime called netwrite, which is a container-based, runtime that you can use. So what it does is it stores the state for you for the developer. So it's easier to look at the code and assemble. So let's imagine this is the simplest scenario: function chaining. An order comes in. I'm going to check inventory first. Then I'm going to send a request to the payment provider. Then I will wait for it. I will get a response. Then I'm going to send another message to, or an HTTP call to the shipping company, whatever, right? All of these are steps. And all of these are separate functions, let's assume. And one function does one thing, F1 does its own thing, and then puts the work item into the queue. F2 takes it. So the beautiful part of this is that every function can actually scale separately. Because here's the deal. You receive an order. You are processing the order, but then you have to process every item in the order. So let's assume there's 10 items in the order. When it comes to order processing, you have one execution cycle. But when it comes to item processing per order, you have 10 execution cycles. So in this case, if the F1 is the order processing, F2 is the item processing, having the ability to scale F2 separately from F1 so that F1 works one time. When it comes to F2, in the first queue, you have 10 jobs, and F2 can automatically scale because there are 10 jobs. It scales to 10 instances, parallel processes all 10 of that, and then we come to F3, which is going to be executed when all of the 10 orders, all of the 10 items has been processed. If you do this over networking, like having separate queues, it's painful. I mean, one problem for those of you who did in the past development, I'm sure you're going to empathize with this. F2 will process in parallel 10 times. I want F3 to process only when all of the 10 instances are completed. Go ahead, implement that. It's a huge problem. It's a distributed engineering problem that is not easy to solve, trust me. You have to wait for 10 servers to complete so that you can do your own thing. Imagine the communication I have to have with these 10 servers and the synchronization. So I only run when those 10 servers are done with their job. And I have to optimize this whole thing because I don't want to wait actively. Otherwise, I'm paying for it. And I have to wait passively. So how this whole thing, I mean, this is something that most of the companies do implement today. This is not a very foreign implementation. But here's how we do. And I'm going to go and show you this on the fly. So I'm going to go and say, hey, create me a function. And hopefully it's going to bring up the cold start stuff. OK. So there's a template that you can straight bring in and show to your customers if you wanted, which is, I cannot multitask. Where? OK, there we go. Durable functions orchestration. This is the long name, whatever. I'm not going to change it. I'm just going to go with the defaults. It doesn't matter. There we go. So the only thing that we have to look here is, I wish I could make this smaller. This is a single line, by the way. I know it looks a little bit complex, but here's the deal. So I have a function below that says, the name is say hello, OK? But I want to run this sequentially and say hello a couple of times, but in order, right? How do I implement that? Here we go. So I am essentially saying context call activity as sync. I'm adding it to my outputs and then returning the outputs. What is happening here? The magic is the await keyword. It's the task parallel library working behind the scenes. This is the same implementation that works in a machine when you're building multi-threaded apps, right? But this works across the network. So when this function starts running, when it comes here to the await, the runtime will kill this function instance. So if it took 5 milliseconds to come here, this is going to be killed. It's going to understand that, hey, you want to call say hello with the parameter Tokyo. OK, I'm going to do that call. Behind the scenes, it's going to put a queue item into a queue that is managed by the runtime, and another function will actually take it. But this is the simplicity of my implementation. I'm actually chaining function 1 to function 2 at this point. And because my originating function is killed, I'm not paying for it to wait. So the second function will trigger. It will work. I will pay for it. It will return its value. Then this function, the orchestrator function, will start from scratch. I know it's kind of sounds, hey, why does it start from scratch? Because that's the best we can do. It's going to run from scratch. It's going to come here. But this time, the runtime will notice that, hey, this task, I've already executed that. And I have the result of it. So let me feed that in and continue. So it's going to come here. And then this TPL task doesn't execute, is not executed. So I'm going to do another call to the same function and send another parameter. So essentially, I am chaining, in this case, the same function with 3 different parameters. But this could have been 3 different functions as well, right? And from an implementation perspective, this is all I care. So this is going to start from the beginning. Call this, kill, rewind, replay. It's called actually replay in the documentation. So it's going to replay, recognize that this is filled in, jump into here, call the function, kill the orchestrator. So you're going to see a lot of replays. And at the end, what you're going to see is the final function, once this is executed, my orchestrator will come to this, and it will return the total value I received from a lot of functions. So there is no queue connection. There is no message polling. There is no serialization. There is nothing. I am doing cross-network distributed workflow processing like I am working on a single machine doing things with multiple threads. So here's something else I want to show you. OK. So what about this? This is the problem that I've described. This is the tough problem. We have function 1 triggers an n number of instances of function 2, but then we want function 3 to wait for all of them to complete. So I am going to bring some code, and it's in my slides here, hidden. OK. Go away. OK. So what's the difference? So I'm still calling activity as things, but I'm not awaiting them at that line. What I'm doing is I'm calling all of them because these are going to return tasks. Me not awaiting means they're not completed. They will just return task of string. Then I'm doing task when all. Oops. So I literally, this could be in a for loop. I literally said, hey, call this function with all of these parameters separately, and I want to wait for all of them to complete. And this is the complexity of my implementation. I'm done. This could be a for loop looping through an order, number of products, whatever. So in this case, my code, my orchestrator will run until here. It's going to be killed. My orchestrator will replay when all of the tasks are completed. Otherwise, it's not going to replay. So I'm not going to pay for it until all of the other tasks are completed. So there's another one, and we're getting close to the end of this. So let me show this one as well. Actually, not this. This is much more nicer. And I know it doesn't explain anything. So let me bring in the code. Okay. So this code. Where did it start? OK, task when all. So I will bring a piece of code in here and paste it. So here's the interesting part. So in this code, I have the when all, the upper part doesn't matter. So what I'm trying to do here is, hey, I have a workflow where, like waiting for 3 different tasks to complete. This time, I want to wait on 2 different things. One is a timer. I want to wait for 60 seconds. I want to wait for 60 seconds to complete. It doesn't matter if it's an external function that runs on another server or a time box, right? I want to wait for 60 seconds. Meanwhile, I want to be able to wait on an external system to notify me. So this is, for example, the scenario of a text message challenge. You have a login system, right? You send a text message, you wait for 30 seconds for the guy to put the pin in. If it doesn't put the number in, then the timer has to expire. If it puts the pin in, then you have to move. Yeah. But then you don't want to wait actively for any of those. I don't want to pay for the compute and wait actively. So in this case, what I'm doing here is cancellation token. It doesn't matter. So what I'm doing is I'm creating an expiration time, 20 seconds from now, right? Or maybe 60 seconds, right? I'm creating the timer for it. It returns a task. Keep in mind that I'm using the context because the time, for example, the time in terms of now, it's important to get it from the runtime, because otherwise, during my replay, the definition of now will be different. I don't want that. During the life cycle of a single function, you are starting from here, coming here, and you are deciding, instead of wait, because you cannot wait, you are killing this thing off. You're replaying it back. You are filling in the values and continuing your execution. When you are replaying and continuing your execution, I don't want to get a new now. I want to have the old now. So that's why every time we talk about time in our implementation, we go to the orchestrator context, because it does know that, oh, this is a replay, and I know what time it was when this was run for the first time, so I'm going to give you the old now, so you feel like you have been restored, right? So that's why I'm getting the timer from the runtime as well. I'm not handling the timer myself. I'm creating a timer. It's returning me a task. Oh, I know how to handle tasks. Then I am creating a task from this API called wait for external event. This event will send me an integer number, and the name of the event is this. This is going to expose an HTTP endpoint by the runtime. We can get that when we run this as part of the output. And then I will be able to hand that endpoint off to anyone. If the third-party system sends a request, my code will revive. So here, when I say, when any, I have 2 tasks, the timeout or the external event. When any of those happens, revive yourself. So the timer is handled already by the runtime. The external event, I have the endpoint provided by the runtime to me that I have handed over to someone else, right? If they hit that endpoint, I will revive and continue my execution. And think about it. We have this workflow. I'm going to wait for 24 hours, wait for an external event to happen. If it doesn't happen in the next 24 hours, I want to continue my execution. And during that 24 hours, I'm not going to pay anything because my code is not running. So all of this, as you can imagine, there's a awareness state that is being handled by the runtime, right? That state is stored in Azure Storage, and I will pay a little bit of it. It's literally nothing, right? But other than that, I don't have any cost. This could wait for 6 months for an external event to happen, and you wouldn't pay a dime. Go ahead.
So you mentioned that the context datetime or information that will be persisted in a Azure storage. That's right. But Azure storage in general, it have kind of limitation. Okay. Yeah. So when we think, for example, about replication factors or disaster recovery scenarios, or for example, global solution that distributes across the region, what is there an option that I can override that with using SQL or something else?
Yes. So the durable functions runtime can work with. Do I have those in the slides? I don't think so. Oh, yeah, there you go. Azure Storage, Netherite, based on event hubs, or durable task.sql server. So if you have a SQL server, it will work. But keep in mind that just the storage is not enough. You have to, when it comes to regional replication and stuff like that, or geo availability, you have to have a deployment of the Azure function as well, right? And it's going to be a little bit tricky because I'm not sure how you're envisioning this, but if you have a replicated SQL server and you have two separate function apps running against it, you might have duplicate executions as well at one point. So a failover scenario is much easier. When it comes to global, I believe it's tough. You have to think about those systems separate and build your own integration between those two, right? Maybe, in terms of your business implementation, you would most probably rely on something like Cosmos DB, but the runtime will work regionally within the data center itself. The runtime itself will not be aware of the cross-regional presence. Does that make sense? Okay. Yeah, I have to wrap. I know. Okay, so I have a couple of notes in here that I'm not going to go through it. You can read it. I will share the slides. It's not a huge deal, but when it comes to those replays, you have to be very careful. The one most important thing is the orchestrator itself shouldn't do any work other than orchestration. Because imagine if you upload a file, for example, in the orchestrator, during that replay, that file will be uploaded like 1,000 times with every replay. So the replays should be purely orchestration. If you need to upload a file or do something, an activity, an external orchestrated function should do it so that I can know and track its execution in state so that I don't repeat it again, right? But the orchestrator will be always repeated. Okay. So a couple of links in case those help. So there are, at the beginning I mentioned like the Azure function can run anywhere, but there's some, there might be some limitations and dependencies on the Azure storage in terms of the bindings and triggers. So there's a list there on the link. You can figure out what triggers and bindings require, an underlying Azure storage system, and that kind of helps to understand if you can run on-prem without Azure Arc or not, right? Oh, this one is not related. the Logic App workflow definition language. Durable task framework, if you're interested, and the functions NuGet package if you want to, implement that into one of your apps. And that's pretty much it. The slides are up there. The code samples are in that repo as well if you want to grab. Thank you. Any questions?
Is there any kind of error and exception management built in the durable function framework?
Nothing different than anything you know about .NET. There is logging mechanisms that works out of the box. When you go with the isolated, you can implement pretty much everything that you know that relates to logging and instrumentation about .NET, right? It has its own. It puts a bunch of stuff. For example, with every execution, it actually puts a log into, for example, if you have application insights connected to it, you can go and figure out like things like, what is the instance ID? If it's scaled, right? What is this execution where what instance ID it came from, how many milliseconds it used, all of that is logged into the application insights that you can see. And the exceptions, because I believe what you are worried about is not the exceptions that you create, is like the exceptions that come from the runtime. Those are going to be sent into the application insights if you have one connected.
Okay. So when all, for example, like when all visits.
That's going to be you. You have to take care of that. It's going to throw the task or whatever, the TPL will throw an exception back, and you have to handle that yourself. Yeah.
Next question.
Two questions. Thank you for the session. First of all, you mentioned earlier that the function has 10 minutes limit. So for the durable function, if it's fan out and it takes longer time, so does the limit apply?
No, a durable function can run forever.
Okay, the second question, the one
because
that
it's not actually running, right? That's kind of the point. For example, the orchestrator, if a single execution of an orchestrator, if a single play, let's say, like plays and replays, right? If a single play takes longer than 10 minutes, by the way, I'm not 100% sure about the 10 minutes. We have to check on the documentation. It's 10 minutes? Okay, cool. If you go with the premium plan, again, you don't have it. But anyways, the single execution and single play cannot exceed 10 minutes. But the point is, an orchestrator can pause and resume forever. You can have a for loop, an indefinite while loop in an orchestrator. As long as you have some snapshotting happens because you are calling a task or something or waiting for an external event, you can run that orchestrator forever. There's actually an implementation of this in a way that it gets really closer to the actor model. So they live forever. If you're interested, look into it. There's an actor API on top of durable functions that I didn't talk about.
Perfect. The second question earlier, you mentioned you can define frequency for polling in blob trigger function.
Yes, host.json is the file where you're going to define it.
But isn't that there are three types of functions? I had an impression like one is timer trigger, HTTP, and the data trigger. So you can also define the frequency in the blob trigger, in the data trigger function as well.
You can define the frequency if you go with the polling, which is the default right now. For blob trigger, right? We're talking about the blob trigger. By default, it does polling into the blob storage and checks if there's any file. That polling, the frequency of that polling, you can customize that. You can configure that.
Okay, thank you.
Yeah, you're welcome.
In the sense of time, I think we should
cool.
wrap up.
Thank
Thank
you.
you.